Okay, the next section of this lesson is rational number operations. And as you can see here, we're going to review how to add, subtract, multiply, and divide rational numbers. And you know rational numbers also include integers, so we need to review how to deal with the signs. So it says addition. If the signs are the same, we add the numbers and use the same sign. But in case the signs of the two numbers are different, we subtract and keep the sign of the number with the greatest absolute value. We can call it the biggest with quotation mark, just because we know that negative 10 will never be bigger than 2, but is the biggest in distance from 0. So we're going to keep the sign of the biggest number away from 0. So right now let's practice a little bit here. Oh, I have a song that might help you remember this. Some of you have heard it or not. Let's see.
Same sign, add and keep, different signs subtract. Use the sign of the bigger number, then you'll be exact. Same signs, add and keep, different signs subtract. Use the sign of the bigger number, then you'll be exact.
And so that might help you remember when you have to add numbers that have different signs or the same sign. So same side signs, add and keep. So here we need to add 6 and 2/3 plus 1 and 3/4. The first thing that I suggest is let's rewrite these two numbers, 6 and 2/3 plus 1 and 3/4 vertically, and then we find a common denominator between 3 and 4, and I think that is gonna be 12. So I find a number that times 3 gives me 12, which is 4, and 2 times 4 is 8. So now I have to turn fourths into 12. So 4 times 3 is 12, 3 times 3 is 9. And now I have these fractions with the same denominator. So 8 twelves plus 9 twelves, we have 17 twelves. Then we turn this into a mixed number. I know this is a 1 whole number and 5 twelves. I must not forget these whole numbers that I had originally here. So I need to add 6 and 1 is 7 plus this 1 whole number that we figured out previously. So the final answer is going to be 8 and 5 twelves. And there you go. You box that answer. Then we have another example with rational numbers again, but these have different signs. So same signs, add and keep, different signs, subtract. So at the end, we're gonna have to subtract 5 minus this little half. So what is the greatest absolute value, or the number that is farther away from 0? In this case is 5. So my answer is gonna be negative. So I'm gonna lock that up. And I'm gonna now proceed to subtract these two numbers. I have 5 and 2/5 minus 1/2. And so I need to turn them into a common denominator, which in this case is going to be 10. And then I go 5 times 2 is 10, 2 times 2 is 4, 2 times 5 is 10, 1 times 5 is 5. And if you notice, 5 is bigger than 4, so we cannot subtract. But we have this guy that has like a lot of numbers. Oh, it has 5 ones. So I'm going to borrow one whole, and this one whole that I'm borrowing, I'm going to make it 10 tenths. So if I add those 10 tenths to this 4 tenths, now I have 14 tenths. So I can subtract 14 tenths minus 5 tenths, we have 9 tenths, and then 4 minus nothing is 4. So my answer is 4 9/10, but previously I had decided that my answer was going to be negative, so I just plug it in here. And there you go. We have the answer of -4 and 9/10. Then we have subtraction. To subtract, rational numbers that include positive and negatives, we need to rewrite the problem actually to addition of its opposite. And some of you know this as using KCO. We keep the first number, we change to addition, and we change the second number to its opposite. So when I see positive and negatives and then a subtraction, I know this subtraction is going to turn into addition. So I suggest you always write KCO. That way it reminds you that you have to rewrite this operation. You keep the first number, -4 and 1/5, plus, and I see that this guy is a positive number. So the opposite of a positive is a negative. So this is a -2 and 1/10. I'm going to use parentheses just to notice that this is a negative and this is a negative. So then after this, you go back to the addition of rational numbers rules. So these are same signs, add and keep. So I know my answer is going to be negative. So I'm going to lock that up. I've already took care of the sign. Now I'm going to add these two numbers. So I go 4 and 1/5 plus 2 and 1/10. And here we turn the 1/5 into tens. So 5 times 2 is 10. 1 times 2 is 2. We have 2 tenths plus 1/10. We have 3 tenths. And then we have 4 plus 2 is 6. So the final answer is 6 and 3 tenths. We previously decided the answer must be negative. So the answer is -6 and 3 tenths. Then we're going to do another little example on subtraction. Here we have 2 and 1/4 minus 3 1/2. So I see a subtraction. I go KCO. We keep this, the first number. So it's 2 and 1/4. Change subtraction to addition. The second number, I see that is positive. So I'm going to turn it into a -3 and 1/2. So same signs, add and keep, different signs, subtract. So 3 minus 2 is going to be 1, and the biggest number is -3. So my answer is going to be negative, and I'm going to lock that up. Once I take care of the sign, then I now have to subtract these two. So I'm going to write 3 and 1/2 minus 2 and 1/4, and I can just turn 1/2 into 2/4 easily. So I go 2/4 minus 1/4 is 1/4, and 3 minus 2 is 1. 1 and 1/4. Previously, we decided that the answer must be negative, so this is a -1 and 1/4. And there you go. That's subtracting rational numbers. All right, and last but not least, multiplication and division are rational numbers that includes positive and negatives. And these two operations are very easy, but don't confuse them with add and subtract. When you multiply and divide, they have pretty much the same rules. If you have the same signs on both numbers, your answer will be positive. If you have different signs on the numbers you're multiplying or dividing, your answer is always negative. And I know some of you also use little tool here, Dorito guy, and I know you write positive, negative, negative, and then you circle the two factors, so the two numbers that are divided, and if you have two negatives, you circle these two, the answer is positive. If you have a negative and a positive, you circle these two, and the answer is whatever is all circled. Whatever you use, as long as you get the correct sign when you get the answer, it's cool. And also I have a little song that you can remember in case you know you remember this. Maybe you remember the little tool here. Let's see here, and I remember connectivity.
Negative, yeah, same signs, positive, different signs, negative.
So let's see. Let's hear it up.
Follow the signs, positive.
There. Different signs, negative,
yeah,
same signs, positive, different signs. Okay, maybe some of you remember that song. Okay, so Now we're gonna practice, those rules. We're gonna multiply here negative 2.7 times negative 3. And these two are the same sign, so same signs, positive. So we can log our answer. You don't have to write the positive, but it's just like peace of mind that you already figure out the sign. And after we figure out the sign, we proceed to multiply. So we multiply 12.7 times 3. And we got 3 times 7, 21. You carry 2. 3 times 2, 6, and 2, 8. 3 times 1 is 3. And we have one decimal place and one of the factors, so one decimal place on the product. The answer here is 38.1. And it was positive because same signs, positive. So here we have another multiplication, negative 9.6 times 5. So here I see negative and a positive, so same signs, positive. Different signs, negative. So here I'm going to lock up the answer. I know it's going to be negative, so I'm going to multiply 9.6 times 5. And I don't have to write the negative because I already figured that out. So it's 5 times 6, 30. You carry 3. 5 times 9, 45. And 3, 48. One decimal place in one of the factors, one decimal place in my product. So the answer here is 48, or negative 48 actually, right? Okay, and then we have an example of division. Here we're dividing negative 60.8 by 4. So different signs, negative. So we lock the answer is going to be negative, and then we divide 60.8, and this is how we solve a division. This is how we write it. We read negative 60.8 divided by 4. So when I write that down, I do think of it this way: 60.8 divided by 4. And then we have, okay, there's no decimal on the divisor, but there's one decimal right here. All we have to do, you see, we move it up, and then we proceed to divide. We go 4 times 1 is 4, remainder 2. We drop the 0, and then we go 4 times 5 is 20, remainder 0. Then we drop the 8, and then we go 4 times what equals 8 is 2. 2 times 4 is 8, remainder 0. So we know that our answer here is 15.2. So in reality, it's negative 15.2. And the last division that we have here, it's a little simpler. Both are positive. Our answer is going to be positive. We don't have to worry about looking up any answer here, positive. But this has just a little bit of a trick here. We say 100 divided by 2.5. And we see that our divisor is a decimal, and nobody wants to go out with a piece of a number. We need to make sure this number is a whole number, so we move the decimal once to the right, and we do the same inside the house. So in reality, what we're going to be dividing here is going to be a 1,000 divided by 25. So we forgot about this one, and this is the one that we're going to work with. So we have here, I know this is going to be a little easier because, hey, 25 is a benchmark. So I know how many times 25 goes into 100, which is 4. 4 times 25 is 100. Remainder 0. We drop the 0. Sure respect, 0 is also a number. How many times 25 goes into a 0? And the answer is 0 times. So we do the proper work, and we know that 100 divided by 2.5 equals to 40. And that concludes our lesson for the day. And after this, depending what your teacher is assigning, you can use these notes to help you get the correct answers for your assignments. See you next time. Stay tuned. Bye-bye.